Hello, hi everyone. Welcome to the Story in the Brand. So this is your Siva sir. Today we are going to discuss about electric current, CBSE Grade-10 physics. Hello, hi everyone. Welcome to the Story in the Brand. So now we are going to discuss about electric current, electric current, electric current, electric current. So electric current we are discussing. So the rate of flow of charge is called electric current. The rate of flow of charge is called electric current. I equal to Q by T. I equal to Q by T. SI unit of electric current is ampere, SI unit of charge is coulomb, SI unit of time is second. Okay, so now we can see here. So I equal to Q by T. SI unit of current is ampere. So here I am taking this is ampere. SI unit of current is ampere. Ampere. And the SI unit of charge is coulomb. SI unit of charge is coulomb and SI unit of time is second. SI unit of time is second. Okay. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So that is nothing but electric current. And the SI unit of electric current is ampere. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. Okay. So now here you can see. So Q equal to NE. Q equal to NE. So why we are taking NE? Because quantization of charge. Q is the quantization of charge. So here you can observe. So electrons are moving inside of the conductor. Electrons are moving inside of the conductor. So will you able to say only one electron flows, current is flowing, only two electrons are flowing, current is flowing, only three electrons are flowing, we can say current is flowing? No, we can't say like that. Okay, number of charges are moving. Okay, so number of electrons, number of charges are moving, then we can say current is flowing. So that is Q equal to NE. Q equal to NE. N is the number of charges are moving inside of the conductor. Number of charges are moving inside of the conductor. So N is the integral multiple. So we can take on one electron. On one electron, how much charge is present? 1.6 into 10 power minus 19 coulomb. Okay. On one electron, 1.6 into 10 power minus 19 electrons. Okay. So on one electron, 1.6 into 10 power minus 19 coulomb. Okay, in 1 coulomb, how many electrons? 1 by 1.6 into 10 power minus 19. So that can be written 1 by 1.6. So 1 by 1.6 into 10 power 19. 10 power 19. So if you solve this one, we will get 0.625. 0.625. Okay, so 0.625 into 10 power 19. Okay, so electron in 1 coulomb. In 1 coulomb, 0.625 into 10 power 19 electron. So 0.625 mentioned, right? So now we take, so 1 coulomb 6.25 into 10 power 18 electrons. 10 power 18 electrons. Okay, so that's enough. Now, so based on this one, so there are questions. So define 1 ampere of current, or define define current, electric current. Define electric current. So electric current is defined as the rate of flow of charge. The rate of flow of charge is called electric current. So define SI unit of electric current. Define SI unit of electric current. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. Okay, so that is about SI unit of electric current. Quantization of charge. What is quantization of charge? Quantization of charge is nothing but, so electrons, only one electron is moving. We can't say current is flowing. Only 2 electrons are moving. We can't say current is flowing. So there are many charges, many electrons are moving inside of the conductor. That's why we can say, that time only we can say current is flowing. That is charges. So that is quantization of charge. Q equal to Ne. Q equal to Ne. So N is the number of charges. Number of charges are moving inside of the conductor. Yes. Yes, on one electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 1 by 1.6 into 10 power minus 19. So if you are taking 10 power 19 upward, so 1 by 1.6 into 10 power 19. Okay, in 1 coulomb, so in 1 coulomb, 1 coulomb 0.625 into 10 power 19 electrons. 19 electrons. So 1 coulomb 6.25 into 10 power 18 electrons. 18 electrons. Okay, so this is the answer. This is very, very important. So we can expect 1 mark from this question. We can expect 1 mark question, 1 mark from this question. Okay, so quantization of charge. So electric current definition and SI unit of electric current, and definition of define SI unit of electric current, quantization of charge, and on 1 electron how much charge is present, in 1 coulomb how many electrons are present, everything it will be. Okay, so this type of questions they will ask in an exam. Okay, so next one, so we will discuss about, we are going to discuss about actually human in colorful world. So we have to discuss human in colorful world and magnetic effects of electric current, that we need to discuss. Now we are discussing about electric current. Electric current. Electric current. So yes. So where we are? Electric current. Now we are going to discuss about electrical elements. Electrical elements. What are those? Electrical elements. So I'm taking the positive term, negative term. That I'm taking the, so that is cell. Okay, so cell. Next one is, so 2 or more cells together, that is called battery. Okay, so I'm taking this a battery, and open switch. Third one is open switch. This is a open switch. Next one, closed switch. Fourth one is closed switch. Here is open switch. Next one is closed switch. Okay, so next one we are resistor. What is a resistor? Resistor is a device which is used to oppose electric current in the circuit. Resistor is a device which is used to oppose electric current in the circuit. Resistor. Resistor is a device which is used to oppose electric current. Resistance is the phenomenon of opposing electric current. Resistor is a device which is used to oppose electric current. Resistance is the phenomenon of opposing the electric current. Phenomena of opposing the electric current. Next one, rheostat. Rheostat, 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 rheostat. Okay, rheostat is a device which is used to regulate the electric current without changing the voltage source. Rheostat is a device which is used to regulate the current without changing the voltage source. Okay, so that's enough. So cell, battery, open switch, close switch, resistor, rheostat. Next one, ammeter. Ammeter. So I'm taking this ammeter, positive terminal, negative terminal. So next one, voltmeter. Voltmeter I'm taking like this. Next one, so wire joining, this is a wire joining, and 10th one, wire crossing, this is a wire crossing. Next one is bulb. 11th one is bulb. So ikkada meer, so now if you observe here, ఇక్కడ కానీ చూసినట్టయితే సెల్, బ్యాటరీ, ఓపెన్ స్విచ్, క్లోజ్ స్విచ్, రెసిస్టర్, రియోస్టాట్, ammeter, voltmeter, wire joining, wire crossing, and bulb. Okay, so these are all electrical elements. So now, we will discuss about electric circuit. What is electric circuit? So electric circuit is nothing but, so a continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. So now electric circuit, electric circuit, electric circuit, electric circuit, electric circuit. A continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. So here I'm taking the bulb. So this is the bulb. Okay, so ammeter. Next one is, so battery. So switch, current is flowing here. Okay, positive terminal, negative terminal, current is flowing. So here you can observe a continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. Hi, welcome to the class, everyone. So here first one is conventional current. So conventional current. So if you are new to the channel, please do like, share, and subscribe to Student the Brand, and share to your friends. Ask your friends to join to the class because live class is going on. So conventional current. So what is a conventional current? Conventional current. So conventional current is nothing but the flow of positive charges. Flow of positive charges is known as conventional current. Next one, electric current. Electric current. So conventional current is nothing but the flow of positive charges is known as conventional current. So positive charges are moving. So that is about conventional current. So positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. Conventional current is nothing but flow of positive charges. So positive charges are moving from positive terminal to negative terminal, whereas electric current, electrons are moving from negative terminal to positive terminal. So here you can see positive charges are moving from high potential to low potential, whereas electrons are moving from low potential to high potential. high potential. So that is about conventional current and electric current. So based on this one, so there are questions. So point number one is, what is conventional current? What do you mean by conventional current? Conventional current is nothing but flow of positive charges is known as conventional current. So electric current is nothing but flow of electrons are known as electric current. Okay, so positive charges are moving from high potential to low potential, whereas electrons are moving from low potential to high potential. Yes, I will take classes. So electrostatics. Yes, definitely. Okay. So share to our friends. Do like, share, and subscribe to Student the Brand. So follow the channel definitely in further. So upcoming classes definitely will introduce all the classes. Okay, so all the topics. So now electric current. Electric current is nothing but, so the flow of positive charge, flow of electrons. Electrons are moving from. Okay, so if you need any details, you can contact to this number. So we will discuss 98498 Okay, so we'll discuss. Okay, done. Sure. So regarding reminding everything, so all the details we'll discuss. Just you can contact to this number. Just ping me. So further details we'll discuss. Okay. So now you can observe conventional current. Conventional current is nothing but the flow of positive charges. Positive charges are moving from high potential to low potential, whereas electric current. So electrons are moving from low potential to high potential. So conventional current and electric current. So I hope it is very clear. So electric circuit. So the flow of a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. I hope it is very clear. Next one. So we will discuss about so that is about electric circuit, conventional current and electric current. So before that we discussed the electric current, and so after that we discussed the electrical elements. After that electric circuit. Now, so after this one, so we will discuss about potential difference and electrical potential. Potential difference, potential difference, potential potential difference, potential difference. Potential difference is nothing but work done to bring unit positive charge, work done to bring unit positive charge from one point to another point within the conductor. So I am taking point A and this is a point B. We are doing some work. We are doing some work to bring unit positive charge. I am taking the positive. We are doing some work to. So we are doing some work to bring unit positive charge from one point to another point within the conductor. Within the conductor. Within the conductor. Within the conductor. That is called potential difference. Potential difference. Potential difference is nothing but work done to bring unit positive charge from one point to another point. So coming to electrical potential. Electrical potential. Electrical potential is nothing but electrical potential. Work done to bring unit positive charge. Work done to bring unit positive charge from infinity to the required field. Potential difference is nothing but we are doing some work. We are doing some work to bring unit positive charge from one point to another point within the conductor is called potential difference. Electrical potential is nothing but work done to bring unit positive charge. So I am taking the positive charge. So here you can observe. So this is infinity. This is the required field. Required field. So we are doing some work. We are doing some work to bring unit positive charge from infinity to the required field. From infinity to the required field. So V equal to W by Q. V equal to W by Q. So here there is one definition, that is, so volt. So 1 volt is defined as, define 1 volt. 1 volt is defined as, 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. Okay, so if you are taking the within 2 points, we can say work done to bring unit positive charge from one point to another point within the conductor is called potential difference. So here especially define 1 volt means 1 joule of work is done to bring 1 coulomb of charge from one point to another point, right? So that's enough. So this is about the potential difference and electrical potential. So now we will discuss about Ohm's law. Ohm's law. So Ohm's law is nothing but work done to the potential difference. The potential difference across the ends of the given metallic conductor. So the potential difference across the ends of the given metallic conductor, V is directly proportional to I. V equal to IR. I equal to V by R. And R equal to V by I. Okay. So here it's very, very important. Make sure that you are learning this point. Next one, materials required. Materials required. Materials required. Materials required. Materials required. What are the materials required to do this activity? First one, you can observe 4 cells, 1.5 volts each. And the second one, nichrome wire is an alloy of nichrome wire is an alloy of nickel, chromium, manganese and iron metals. And we can take, so ammeter and fourth one is voltmeter and fifth one is switch and sixth one is connecting wires. So materials required, first 4 cells, 1.5 volts each, nichrome wire 0.5 meter length, ammeter, voltmeter, switch, connecting wires. Okay. So now circuit diagram will draw. This circuit diagram. So actually we have to take a resistor. Here we have to take resistor. That is nothing but nichrome wire. Okay, so now you can observe here. So procedure is a circuit diagram. 1, 2, 1, 2, 3, 4. Okay, 1.5 volts each. And a nichrome wire is 0.5 meter length. And so here, first you have to connect one cell, and note down the reading of ammeter and voltmeter. Second one, two cells, connect to two cells, connect to two cells. So two cells you have to connect. Two cells you have to connect and observe the reading of ammeter and voltmeter. See, every time you are connecting, first you have to connect one cell and note down the reading of ammeter and voltmeter. And connect to two cells and note down the reading of ammeter and voltmeter. And repeat the process for 3 and 4. So third one, repeat the process for 3 and 4. 3 and 4. Okay. So then, so you have to mention in the tabular form given below. So I'm mentioning the tabular form. So this is the tabular form. Serial number, number of cells required, ammeter reading, voltmeter reading, V by I form. Serial number 1, 2, 3 and 4. Okay. So here you can take serial number. So number of cells, ammeter reading, voltmeter reading, V by I, that is equal to R. V by I is that is equal to R. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. Okay, so first you have to connect one cell and note down the reading of ammeter and voltmeter and connect to two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4 and mention, observe the values of ammeter and voltmeter and mention in the tabular form given below. Okay, so now if you draw the graph for VI, so the VI graph is straight line, V on y-axis, I on x-axis. So the graph is straight line. Okay, so starting from origin. And the next one, if you are taking VI graph, V on y-axis, I on x-axis, the graph is curve. So this is for ohmic conductor. The conductors which obey Ohm's law, those are called ohmic conductors. The conductors which does not obey Ohm's law, those are called ohmic conductors. So once again, so I'll explain Ohm's law. Just listen carefully. So here, the potential difference across the ends of the given metallic conductor is V is directly proportional to I. V equal to IR, I equal to V by R equal to V by I. Materials required 4 cells. So 1.5 volts each. So each 1.5 volts of each. 1.5 volts of each means each cell potential difference how much? 1.5. And a nichrome wire is an alloy of nickel, chromium, manganese and iron metals. This is the nichrome wire. And ammeter and voltmeter and switch connecting wires. So these are the connecting wires. So this is about circuit diagram. So there is one question related to this. So they will ask. So draw the circuit diagram of, so getting V is directly proportional to I. The graph V I graph is linear. Okay, so circuit diagram. So like that they will ask. So you have to draw the circuit diagram. Okay. So 1.5 volts, say 4 cells. That too you have to draw with the dotted line. Sir, why you are drawing with the dotted lines? Why can't you draw normal lines? Because we are connecting one by one. First you have to connect one cell and note down the reading of ammeter and voltmeter. Next, like that, repeat the process for 3 and 4. Then you have to mention in the tabular form given below. What is the tabular form? 1, 2, 3, 4. So number of cells and ammeter reading, voltmeter reading, and V by I equal to R. So here the graph is VA graph is straight line starting from origin. VA graph is straight line starting from origin. And so this is for ohmic conductor. The conductors which obey Ohm's law, those are called ohmic conductors. And the conductor which does not obey Ohm's law, those are called non-ohmic conductors. So ohmic conductors and non-ohmic conductor, this completely about Ohm's law. Okay, so this is about Ohm's law. Okay, so now now resistance and resistivity, resistance and resistivity, resistivity. So resistance is nothing but resistance is nothing but so R is the resistance is nothing but the phenomena of opposing the electric current. The phenomena of opposing the electric current is called resistance. So R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. Okay. So if more length, more resistance will be there. So at the same time, more area of the cross section, less resistance will be there, right? So that's why I'm taking R is directly proportional to L, R is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. Okay, so here resistivity rho equal to RA by L. Resistivity rho equal to RA by L. So SI unit of resistivity. So what is SI unit of resistance? Ohm. SI unit of area meter square. SI unit of length meter get cancelled. So ohm meter. Resistivity equal to ohm meter. I hope it is very clear. So resistance and resistivity. Resistance okay, so I hope it is very clear. Resistance and resistivity, right? Next, so we are going to electric current, resistance and resistivity. Now resistors are connected in series combination and resistors are connected in parallel combination. So we'll discuss those points. So R1, R2, R3. R1, R2 and R3. So here I am taking V1, V1, V2, V3, R1, R2, R3. So just 1 minute.